I'd like to talk to you today about producing pig meat sustainably. And I'd like to do this in the context of the world population increasing. In 1960, we had 3 billion people in the world. We currently have over 7 billion, and in 2050, it's estimated that we will have 9 billion people in the world. When we talk about sustainability, we talk about ensuring that whatever development we do, that it will not damage the environment. But there are also other pillars to sustainability. There is a social sustainability, and there is economic sustainability. So these three pillars must work in tandem, let's say, and be sustainable. We need to have social, environmental, and economic sustainability for a production system to survive into the future. And these three pillars are often talked about as the 3 Ps: people, planet, and profit. And each of those items is very, very important if a system of production is going to continue. Now, I'm going to ask you to engage with me just for a minute and pretend you're on Who Wants to Be a Millionaire. And the question for 10,000 euros or pounds, if we're in sterling, you're sitting across from Jeremy Clarkson, is which one of the following gases contributes most to Ireland's greenhouse gases? Is it A, ammonia, B, nitrous oxide, C, methane, or D, carbon dioxide? And I need your answer now. The answer is methane. And that's really, most methane is coming from the bovine side of the agricultural sector. But the reason I want you just to look at this slide is that there are 3 greenhouse gases shown here. B, C, and D, nitrous oxide, methane, and carbon dioxide are 3 greenhouse gases. Ammonia isn't a greenhouse gas, but from a pig sectoral point of view, it's an important one, and it's one that we should be conscious of. At national level, agriculture in Ireland is responsible for 1/3 or 33% of the greenhouse gases from the overall economy. And within that, 100% coming from agriculture, the pig sector contributes about 3% of the greenhouse gases. So we're quite small from a greenhouse gas perspective. If we look at ammonia, agriculture is responsible for over 99% of the ammonia emissions from at a national level, and the pig sector is responsible for about 5% of those emissions, excluding the management and spreading of slurry. So let's say it's a larger area, and it's an area that we're probably going to hear a lot more about as time goes on. So ammonia emissions is one we should be very conscious of. So as I said, ammonia is not a greenhouse gas, but there are health and environmental issues associated with ammonia. And at the moment, there is a revision being talked about and been pushed very hard at European level on the Industrial Emissions Directive. Now, at the moment, any pig farm above 750 sows or 2,000 production pigs, i.e. 2,000 pigs above 30 kilos live weight, must apply to the EPA for an industrial emissions license. The proposal that's going through with the current revision of the Industrial Emissions Directive is that any farm with more than 150 livestock units will require an industrial emissions license. And the main driver of that is the link that ammonia has with health and human health issues. Where you have ammonia in the environment or in the atmosphere or in the air, it combines with dust, and that dust can be inhaled by humans and cause respiratory issues such as asthma and issues like that. So that's the background as to why the Industrial Emissions Directive is being driven, but it's more to reduce the ammonia emissions at an overall national level with a view towards trying to improve human health. So it's one area that we need to be conscious of. And I'm just going to stay with the ammonia in this next slide. And this is the ammonia emissions from all of the agricultural sector. So it includes, let's say, the bovine grazing of bovines, dairy cows, or beef cattle as well. But if we take the manure spreading, is 26% of ammonia emissions come from that. The housing of animals, 34% of the emissions come from there, and manure storage, let's say 15% come from there. Now, the implications of this are that in terms of trying to reduce our overall emissions of ammonia, we are now going to have to cover any uncovered outdoor manure storage tank areas. The housing, and particularly for pig housing as we go forward, we're going to be looking at systems of trying to reduce the ammonia emissions from those houses. Now, one area, let's say from a nutritional point of view, obviously, is to reduce the protein going into the pig diet. And by reducing the protein, we're also reducing the ammonia emissions as well. So that's quite an important area. And it's one area that farmers, let's say in Ireland over the last number of years, have been dealing with. As you reduce the emissions of, or as you reduce your crude protein levels in your diets, you reduce the ammonia emissions quite substantially. And the last area then is the area of manure spreading. And under the nitrates regulations now, from 2023 onwards, all slurry coming from pig farms has to be spread using low emissions spreading technologies. So the low LESS system, whether band spreading, trailing shoe or trailing hose, that type of system is going to have to be used for the future. So back to the topic, is the pig meat production chain sustainable? That's the first question. How can we prove that? And that's an important question, and I'll try and address it as we go along. And is this important in the marketplace? And I think, let's say, the last question, the answer is yes. As time goes on, the consumer is going to be more conscious of what is the carbon footprint of the food that I eat. So we have to be aware of that. So at farm level, we need to be conscious of what our carbon footprint is. And at a market level, we need to be able to show that what we do is sustainable from an environmental point of view. And also that what we do, we are conscious of trying to make it more and more sustainable so that we're constantly improving our system of production. This slide shows that this is a figure, excuse me. This slide shows the greenhouse gas emissions from an Irish pig farm in the year 2010 as part of a study that was done then. And it shows that the carbon footprint comes in at lower than 5 kilos of carbon dioxide equivalent per kilo of pig meat produced. When we talked earlier, we mentioned the carbon dioxide, methane, and nitrous oxide as the three greenhouse gas emissions from agriculture. Those are always converted into carbon dioxide equivalent figures to give an overall carbon footprint for the production system. So in Ireland, when this study was done by the European Commission, the report showed that the output figure for Ireland was less than 5 kilos of pig meat per kilo of pork, which came in a lot lower than some of the countries involved. Future market access, we need to be conscious that our carbon footprint will become more of an issue in the future, and sustainability, let's say, of the system is going to come under the microscope more. Carbon footprint calculations can vary depending on what you include. And while you saw on the slide, the previous slide, that Ireland had a good carbon footprint, it is important that we understand how that calculation or the model to calculate that was derived. Another study in 2017 showed that the global warming potential of pig meat was 3.5 kilos of carbon dioxide equivalent. It's the same parameter in terms of your carbon footprint. So 3.5 kilos carbon dioxide equivalent per kilo of pig meat was the figure in 2017, based on the average performance on the pig farms in Ireland as per the profit monitor produced by Teagasc. So how can we show that the production chain is sustainable? The Carbon Trust has worked independently and validated a model on the beef side, and a lot of people will be aware of the Carbon Navigator. And in 2015, the Teagasc Pig Development Department linked with Board BIA and the Carbon Trust to develop or look at least at how would we start to develop a carbon calculator or a model to calculate the carbon footprint of pigmeat. And work was done to develop this model. It's called the Carbon Navigator Tool for Irish Pigmeat. That may not be the final title for it, but the idea was to look at pulling information in, the relevant information into a system, and deriving then the calculation of the carbon footprint for the Irish pigmeat production. The input items that are required, and this is just a list of them, obviously the farm name, the herd number, and all of that would be in the background, let's say specific only to the farmer and to the report that was generated. But then you would have the number of pigs that were produced in the time period, and generally what you'd like to do is develop an input sheet that was going to be over a reasonable period of time. So let it be 12-month period. The average carcass weight and the total feed used per pig. And each of those figures then, let's say we looked at the amount of, was the feed purchased or was it home milled, and the tons of feed per sow per year, and then the growth rates in the weaner stage and in the finisher stage. The soya source was an important one as well, and that, let's say, came as a drop-down menu. And the was there land change use regarding the soya? Was it, let's say, in compliance with sustainable agriculture or no, or not? If the feed is purchased, what is the distance to the mill? And then we looked at a number of other parameters, looking particularly at the energy usage on the farm, the forms of that energy. Did it come in wood chip, wood pellets, kerosene, or was there renewable sources of energy there used in the farm? The water usage on the farm. And then the last area looking at of input data required was the feed, the ingredients used in each diet fed to the pigs. And that information then, let's say, was used to as the input data for the model. And then the output suggested report was that you would see the total carbon emissions per kilo of pig meat on a live weight basis. And then, let's say, when a breakdown of that showed that the yellow bar here is the selected farm, your own farm, and the red is the average. So you were benchmarking your own farm against the average, which is a nice way to see how good or bad is your performance. But if we look at this, a large component of the overall carbon footprint is coming from the feed. A small component is coming methane from manure management. A very much smaller component is coming methane from the digestive system of the animal, of the pig. And then a very, very minor component again coming from the energy usage on the farm. So these reports have yet to be finalized, but the idea is that in time we will have a model that we can benchmark each farm against the average for the average farms that are on the system, and then see how we can compare, and then see what benefit or what areas we should concentrate on to try and reduce our carbon footprint. When we look a little bit closer at the feed side of things, you can see that you have a starter diet, a link diet, a weaner diet, finisher diet, and a sow diet. And let's say, obviously, on a pig farm, the finisher diet is the most consumed diet, or the largest proportion of feed used on a farm is the finisher diet. And the weaner diet, let's say, would be the second largest, and then your sow diet would be your third. The amount of starter diet and link diet is quite small. They would be the most expensive diets being fed to your pigs. But when you look at it, and just look at the green component of each bar there, you can see that the soya component is the biggest contributor to your carbon footprint. So you can see that of the slide, the previous slide showed a 5.36 kilos of carbon footprint. 3.39 of that is coming from the feed component. And of that, you can see, you know, the soya component is the largest contributor of that. So if we were to reduce the soya used in the diet, well, then let's say it obviously will reduce the carbon footprint. And that's to do with the carbon miles associated with transporting soya from places like South America. So that's the suggested model that we have. And part of the presentation here would be that, you know, the hope will be that we will finalize that model and maybe start to work on a voluntary basis with farmers over the next number of months and see what is the carbon footprint on your farm, and then at least maybe roll out the model to the whole sector for the future. So the question is, why should we do it? And the first answer, I suppose, on that is to help compete in the marketing of pig meat, because this is going to become a component as time goes on of marketing. And one of the requirements from a marketing point of view will be to show that the sustainability of the process is being evaluated, assessed, and improved upon. To show consumers that the carbon footprint of pig meat, let's say, is being measured, and we are working constantly to validate that, but also to improve it. And demonstrate that the efficient production systems are good for the environment. And really, let's say, what I mean by that is that if you have a very good feed conversion, it means you're using less feed to produce the pig meat. Therefore, let's say, when we saw in the previous couple of slides where soya was such a large component of it, we're using our feed more efficiently to generate or to produce the pig meat. Therefore, we're using less soya, particularly to actually to produce each kilo of pig meat, and that will improve the carbon footprint of the system. This slide was really just to put in as a reminder of the constant improvement that's occurring on farms. And let's say in 2012, we would have spoken at the pig conference, the National Teagasc Pig Conference, about producing 2 tons of pig meat from 7 tons of feed. In 2021, when we look at the average output performance, the output of pig meat was 2.549 tons of pig meat, or 2,549 kilos of pig meat per sow. And the feed used was 8.815 tons, or 8,815 kilos of feed per sow, plus her progeny for the year. So that gave you a feed conversion of 3.46 kilos of feed per kilo of pig meat produced. And that's an important figure when we look at the previous sets of data. So if we look at the year 2000, the output, the number of pigs produced per sow in 2000 from our figures, which is the average, let's say, you know, from our database in 2000, is 21.6 pigs produced per sow. The live weight at sale was 90.1 kilos, and with a dead weight of 68.1. The kilos of pig meat per sow was 1,471, and it took 5,385 kilos of feed to produce that pig meat per sow in the year. In total, that bottom line figure of 3.66, it was required to produce 1 kilo of pig meat. In 2010, the output has improved up to 23.9 pigs per sow. The live weight has increased up to 103.6 kilos per pig, with a dead weight of 78.9 kilos. And the pig meat per sow is now, in 2010, is 1.886 tons per sow per year. The total feed there is just close to 7 tons. And you can see that the kilos of feed per kilo of pig meat is 3.69. And that you may get variations up and down, you know, depending on quality of grain, even coming in and previous year's harvests. But as your sale weight goes up, obviously, let's say the feed conversion will also go up. So that may have been a contributor to that slight increase in the kilos of feed per kilo of pig meat. But if we come into 2021, we now have 28.1 pigs produced per sow. Our sale weight is 118.4 kilos live weight with a dead weight of 9.7 kilos. The pig meat per sow per year is 2,549 kilos with produced from 8,815 kilos of feed. And we have a very respectable 3.46 kilos of feed required to produce each kilo of pig meat. So we're achieving a very good performance there relative to the 3.66 and the 3.69. And bear in mind that our live weight here has also, let's say, increased substantially. The number of pigs has increased substantially. And as you increase in live weight, your feed conversion usually goes up as well. So we're improving, a gradual improvement in feed conversion all the way through that time as well. So they're quite impressive figures. And the point I'm trying to make here is that as you have a good production system, i.e. an efficient production system, that is good for the environment. And we should be trying to capture that in terms of identifying what our carbon footprint is and how are we improving that over time. And I think efficient production, an efficient production system is a good production system from an environmental point of view, as well as from a profitability point of view. So there's no conflict of interest there. So with that, I'd like to say thank you. Thank you for listening to this presentation. And I'm glad to have presented here today. Thank you.